Hey, how's it going, guys? So, in this video series, we are going to be analyzing various CPUs, its benchmark, and some of the property that these CPU have. Let's go ahead and start. Like always, we're starting with Panda. I'm going to be copying this path. Let's go ahead and see if there's any. Ooh, tons of null values. Okay, now what we can do is let's go ahead and see. Let's call it df1 p.read csv. So these are two different dataset, it seems like. The first one with V4 has CPU values. What about this one? For the sake of it, we are just going to spend time to analyze the first one. So df For the sake of the video, I will be uploading both of these files in my GitHub. You can go ahead and play with it. Let's go ahead and see. Okay, this is more interesting. Let's go ahead and see if there's any null values. So this is clean. The file that we're using is this one right here, CPU R23 V2 CSV. Okay, let's go ahead and start playing with it. It does not have price, but it does have name. Let's go ahead and choose 10 samples. The first thing that I would want to do is we would want to plot the manufacturers. Value counts. Okay, this is interesting to see there are Apple chips too. Ten and 5 is good enough. It looks like it's better if I increase Size of font, make it 210. It is going to fit on the screen. The X is going to be manufacturer. What is going to be count? Intel is the highest one, and AMD, Apple. In similar fashion, let's go ahead and type value counts. Let's plot these guys. There's going to be an instance where we would want to use Gemini, and it's going to block our code, but that is totally fine for now. Let's go ahead and start grouping. So the column takes less space than the info. We do not need all the details, the type of the data. We just want the name of the column. So over by. Let's go ahead and see what manufacturer makes what CPU. CPU name, unique. Let's go ahead and let the Gemini do its job. Is there any difference in the code that we ran? Let's go ahead and see. Says does not have process. Fine, which is totally fine. Okay, let's go ahead and count total CPU from each new count. Stored values. Looks like Intel has the most we would want to see. All the chips that are manufactured by Apple, all the data, all the rows, all the records. Here we manufacturer equals to Apple. Okay. Obviously, this is not an updated data from recent CPUs, so just bear with me. Also, what else do we want to see? We would want to see the all CPU that has more than 8 cores. Okay. Cores that is greater than 8. These are a lot. So let's count first. There are 54 of them. Now let's go ahead and plot the data. So we are going to count how many are Intel, how many are AMD, and how many are Apple, if there are any. Value count. I'm always confused with count values and value count. Okay, so still Intel is in the top. What else would we want to see? Okay, let's visualize this. Let's plot this. Kind of equals to bar. CPU more than that has more than 8 cores. Okay. On the Y label, let's say number of cores. We are going to list the CPU with the top single score. We don't have to make it complicated. We can just df the sort values, or sort values, of course, on the course single score false. Now let's plot it. Dot plot kind equals to bar. X is going to be CPU name. Y is going to be single score. Title will be top 10 CPU single score. So remove this guy. There we go. Now let's do the same with sort values. False. So these are the CPUs. The top multi-score, because there are 64 cores. Let's go ahead and visualize this. The plot, let's go ahead and plot kind equals to bar. X-axis is going to be CPU name. Y score is going to be multi-score. Title is going to be top 10 CPU for multi-score. Yep. Okay. All right. This is it for now. I'll see you guys in part 2.